For example 3, it says, is the series where I'm taking the sum from n is equal to 1 to n is equal to infinity of 2 to the power of 2n times 3 to the power of 1 minus n convergent or divergent. In this case, we're looking for a geometric series. And for a geometric series, then Tn is equal to a times r to the power of n minus 1. Which means realistically, we're looking for the sum of a times r to the n minus 1. Well, if we're using this formula that we're given here, then what we're going to do is we're going to take it and we're going to simplify it by first changing the order of the power up here, or the exponent, to the negative of n minus 1. Next, because we know that that is a negative exponent now, we're going to move it down to the denominator. And I'm going to have 2 to the power of 2n over 3 to the power of n minus 1. If I have 2 to the power of 2n, then I know that's the same as just 2 to the power of 2, then to the power of n, or 4 to the n over 3 to the n minus 1. Now, what we're going to do is we're going to split this 4 to the power of n. Think of it this way. If I had 2 to the 1 and 2 to the 2 and 2 to the 3, then that's the same as 2 to the 1 and then 2 to the 1 times 2 to the 1 and 2 to the 1 times 2 to the 2. Just adding or splitting up the exponents, which means that I could say that 2 to the 11 is the same as 2 to the 1 times 2 to the 10. And if I look at the relation of the exponents, then that means that 2 to the power of any value is the same as 2 to the 1 times 2 to the whatever the original exponent was minus 1. We're going to use that to split up this 4n. And what we're going to do is we're going to say that I'm taking the sum of 4 times 4 to the n minus 1, or if you prefer, 4 to the 1 and 4 to the n minus 1. And now we can see that there's a common exponent here, the n minus 1, which means that this would be the same as 4 to the n minus 1 over 3 to the n minus 1. And because the same exponent is applied in the numerator and denominator, then I actually have the 4 to the 1, and I'm multiplying that by 4 over 3 to the n minus 1. if I take a look at what my formula is for my Tn, where I have the a and r to the n minus 1, and the values that I have here, I can very clearly see that that is my r value, which means if r is equal to 4 over 3, then it is a divergent series. The absolute value of r is greater than 1. What about using repeating decimals? Well, the pattern in repeating decimals is actually just a form of a geometric series. Anything that is not part of that repeating pattern is just added to the series. It's not actually part of the series, which means that I'm going to start by taking that 2.3, and then I'm going to be adding 0.017, and then I'm going to add to that 0.00017, and then I'm going to add to that, and it's just going to keep moving the decimal place over by 2 over and over and over again, where once again, this part is actually my geometric series. From that, I know from my geometric series, a is equal to 0.017, and I know that r is equal to 0.00017 divided by 0.017, which I can multiply the top and the bottom by 1,000 and just get 17 over 1,700, or just 1 over 100. And if r is 1 over 100, we know that this is convergent. So that means that all I'm doing is I'm taking what is not part of the series, 2.3, and adding that to the infinite sum. Or taking 2.3 plus the first term, 0.017, or if we prefer, let's rewrite it as a fraction and say that it's going to be 17 over 1,000 divided by 1 minus my r value, 1 over 100. This is going to equal, well, 2.3 is the same as 23 over 10 plus 17 over 1,000 divided by 100 over 100 minus 1 over 100, or 23 over 10 plus 17 over 10,000 divided by 99 over 100. that is going to equal 23 over 10 plus 17 over 1000 multiplied by 100 over 99. Or 23 over 10 plus 17 over 990. Now, to give them a common denominator, I'm going to multiply the top and the bottom of this by 99. This is going to give me 2,294 over 990, and the numerator and denominator have a common factor of 2. So 1,147 over 495. There is the reduced fraction of 2.317171717 using a geometric series approach. All right, last example for this chapter. For which values of x is the following geometric series convergent? Now, remember, what does the term convergent mean? Convergent means that the absolute value of r is less than 1 where r is not equal to 0. We can also state that as -1 is less than r, which is less than 1, where r is not equal to 0. What do we know about r? R is term 2 divided by term 1, or in this case, r is just x minus 3. So I'm going to take that x minus 3 and I'm going to sub it in for r. So I'm going to say that -1 is less than x minus 3 is less than 1, where x minus 3 cannot equal 0. And then to get x by itself, what am I going to do? I'm going to add 3. And if I do it in one spot, I have to do it to every side, which means I'm going to be left with 2 is less than x, which is less than 4, where x cannot equal 3. And there's my final answer. That's it. That's limits and functions.